Welcome back. Now we're going to take our factoring to the next level, and we're going to use factoring to solve word problems. And we'll split these up into a couple different videos. Start with our instructions. We want to make sure we identify the variable. We'll write an algebraic equation, so we've got to have an equal sign. And then we'll solve that equation to answer the question. I have included some important formulas for you here. Things that we've seen before but we'll need to remember for these kinds of problems. Our consecutive integers formulas. Consecutive integers, we express them as x, x plus 1, x plus 2. Consecutive even or consecutive odd integers, of course we're counting by twos then. We want every other integer, whether they're even or odd. So x, x plus 2, x plus 4, etc. The area of a triangle is 1/2 base times height. The area of a rectangle or a square or parallelogram is base times height. And something that might be new to you, the Pythagorean theorem, a squared plus b squared equals c squared, or I'll show you that that's leg squared plus leg squared, or the length of the leg squared, equals the length of the hypotenuse squared. And the hypotenuse of a right triangle is the side that's opposite the right angle. It's always going to be the longest side of the right triangle. And then in this section you also have a variety of different formulas. One of the formulas is height equals velocity or initial velocity times time minus 4.9 t squared. You might see different versions of this, but h is height, v is initial velocity or initial speed, and t is time. And again, you'll see different kinds of formulas in your reading, and you'll have to read the problem, and it'll tell you, what the letters represent and what the value that goes with each of those letters are, and then you'll be asked to solve for one of the variables. So you just have to be careful reading the problem and making the connection between what number is represented by what letter and so forth. Okay, so let's take a look at some sample problems, beginning with number 1. If a number is subtracted from its square, the result is 30. Find the number. So let's go ahead and let x equal our number. X is equal to our number. So we want to take our number and we want to subtract it from its square. So that's x squared minus x equals 30. We want to solve this quadratic, so we have to have this equal to 0, so we'll subtract 30 from both sides, and we get x squared minus x minus 30 equals 0. And we solve a quadratic following our process, so we can go ahead and factor. This one doesn't look like it's too difficult, so we'll factor x squared into x and x. I need factors of negative 30 that add up to negative 1, so negative 6 and positive 5. And we get, by using our zero product property, we set each one equal to 0. We get x equals 6 and x equals negative 5. So 6, that one's pretty easy to figure out. 6 squared minus 6 equals 30. So we get 30 equals 30. So that checks out. That's an easy one. One that might throw you a little bit is the x minus 5. So the x is negative 5. Let's see if that works. Well, does negative 5 squared minus a negative 5 equal 30? Okay, well it does. That's 25 minus a minus 5 is plus 5 equals 30. So that checks out. 30 equals 30. So x can be 6 and x can be negative 5. So don't be thrown by that just because x is negative. Doesn't mean we want to throw it out. Negative numbers are numbers too, and they are definitely valid solutions to many of our problems. Second problem, find two consecutive positive even integers whose product is 224. So consecutive even integers. So let's let x equal the first even, and it's a positive even number or integer, so that's could make a difference for us. First positive even integer, so x plus 2 would be the second positive even. So we want to read this problem again. Two consecutive positive even integers whose product is 224. So x times x plus 2 equals 224. Distribute the x, we get x squared plus 2x equals 224. But to solve a quadratic, we need it equal to 0. So x squared plus 2x minus 224 equals 0. We'll go ahead and factor that one. That's not the easiest thing to factor. We need factors of negative 224 that add up to 2. I know my factors of x squared are x and x. And 16 times 14 is 224. So plus 16 minus 14. And we set each factor equal to 0 using our zero product property. X equals negative 16 and x equals 14. And we want even positives. So in this case, since we want positives, we can discount the negative, and our two integers are 14 and 14 plus 2, or 16, so 14 and 16. Moving on to sample problem 3, find two consecutive odd integers whose product is 23 more than their sum. Two consecutive odd integers, so let's let x equal the first odd integer. And consecutive odds then are, of course, x and x plus 2. So we want two consecutive odds whose product, that means we multiply. So let's take x and x plus 2, is 23 more than their sum. So x plus x plus 2. So the product is 23 more than the sum. So if we add 23 to the sum, that will equal the product. So our equation, x times x plus 2 equals x plus 2 plus 23. So x squared plus 2x equals, and x plus x is 2x plus 25. Well, we've got to set this equal to 0, so let's go ahead and subtract 2x from both sides. We'll subtract 25 from both sides, and we get x squared minus 25 equals 0. Well, that's a difference of 2 squares, so that's going to be easy for us to factor. To x plus 5 times x minus 5 equals 0. Set each factor equal to 0, and we get x can be negative 5, and x can be positive 5. So the two consecutive even integers, well, the first odd integer could be, x could be negative 5. So our solutions here, negative 5, and then negative 5 plus 2. So we get negative 5 and negative 3 is one pair of consecutive odds, and the other is 5 and 7. So there are two different solutions here. 5 and 7 and negative 5 and negative 3 both work. And finally, in sample problem 4, the length of one leg of a right triangle is 7 meters less than the length of the other leg. The length of the hypotenuse is 13 meters. So we have a geometry problem here. Of course, I'm going to encourage you to draw a right triangle, which is a triangle with a right angle in it. And I'll identify some of the sides for you. Okay, right triangle has two legs. The two legs come together and make the right angle. And the side opposite The right angle is the hypotenuse. Okay, so the Pythagorean theorem says the length of the leg squared plus the other leg squared equals the length of the hypotenuse squared, or Pythagorean theorem, we could label the sides. We could say that's side A, and that's side B, and that's side C, and sure enough, A squared plus B squared equals C squared. So, the length of one leg of the right triangle is 7 meters less than the length of the other leg. So we have one leg would be x, the other is x minus 7. So those are the lengths of our two legs. And our hypotenuse is 13. So using our Pythagorean theorem, one leg is x, so we get x squared, because we have to square the length of the leg, plus x minus 7, that's the length of the other leg, squared, be careful here with this one, equals 13 squared. So I put this into the Pythagorean theorem. So we end up with x squared plus, now x minus 7 quantity squared, this is one of our perfect square trinomials, it's our multiplication pattern. We should have that memorized. It's definitely not x squared plus 49. It is actually x squared minus 2 times a times b, so minus 14x plus 49 equals 169. So x squared plus x squared, we get 2x squared minus 14x. I'm going to subtract 169 from both sides, and we get minus 120 equals 0. Well, as it turns out, we want to factor this. All of these are even, so I'm going to factor out the 2 out of each. So we get 2 times x squared minus 7x minus 60 equals 0. And now we want to factor that into a pair of binomial factors. So we need factors of negative 60 that add up to negative 7. Well, 12 times 5 is 60, and they're 7 apart. So we have 12, we have 5, so we'll go x minus 12, x plus 5, and that, she smiles, so we get x equals 12, and x equals negative 5. So x represents one of the lengths of the side of the triangle. So in this case, x can't be negative because we're not going to have a negative length. So if x is 12, one side of the triangle is 12. The other side of the triangle is 12 minus 7, or 5. And the other, of course, the given side is 13. So the lengths of the sides of our triangle are 5, 12, and 13. And the legs are both 12 and 5. So there are some sample word problems, and we will see you in class.